Hey, this is Amrit. I'm going to code snake. So first let's play snake. So in snake, all you do is you just use WASD to move around the snake. You collect food and that increases your score. And you lose by hitting yourself or hitting the boundary. Okay? Now let's code it up. First thing you're going to need is an index.html file. Oh, by the way, this is going to be in HTML and JavaScript. Okay, so once you have an HTML file, doc type HTML to tell that it's an HTML file. Then we need the HTML tag, and then the head, which pretty much specifies all like metadata and stuff. Alright, so meta car set equals UTF-8. So like ASCII is like a subset of UTF-8. Yeah. And then we need meta name. We need to specify the viewport, that it is the device's width. Okay. This is just standard stuff we always write at the beginning of every HTML file. Okay. 1.0. Then we need to specify the title, which we'll see on a tab. Snake. That's good. And then let's go. We need to link it to the CSS file. Style sheet. We'll use a CSS file to center the canvas element. Snake.css. Okay. And we need to link the script. So C snake.js. And yeah, that should be good. Yeah, and then we need to add the canvas element, which we'll use to make the game. It has an ID of screen. Yep, that's pretty much it for the HTML file and the CSS file. Snake.css. Okay, so body. First I'll display flex. It's going to be a flex box. Then we need to center it along the center axis and the cross axis. Then we're going to keep the screen, the canvas element, slightly below the top of the screen. So we're going to add a margin top of like 50 pixels. These are all the extensions I'm using if you just want to copy and use the same as what I'm using. Auto close tag, ESLint, IntelliCode. This one also, open in browser, prettier ESLint. Okay. Okay, so now let's create a snake.js file, which will house all the game's logic, movement, keys, everything. Okay. So the first thing we need is to store the screen itself. Let screen the screen width. The screen width is gonna be 510 pixels. Okay. The screen height is gonna be 510 pixels. Okay. And what we're going to use to draw on the screen is going to be the context. Okay, a tile size is going to be 30 pixels. So it's a 17 by 17 screen, because 30 times 17 is 510. Okay, then the snake width is just going to be a tile size. The snake height is going to be a tile size. Let's make that constant. The snake is gonna start. The starting x coordinate is gonna be halfway the middle of the screen, right? So screen width divided by 2. And we have to account for the snake itself. So we'll do snake width divided by 2. Okay? And same strat for y. We change this to height. Okay, so that's done. And when we start, the snake goes down. So the snake starting direction. Yep, like that. Okay, and then the current direction, since we're gonna start south, we'll make the direction equal to the snake start direction. Yep, so we got that. And then we need to store the snake itself, or the player, the main man, the snake. Yep. It's going to be stored as an array. So all the different parts of the snake. It's going to be stored as an array of x and y coordinates. And the only one is going to be the starting one for now, because that's all that exists. So snake start x, snake start y. And also we need the width. We need this, we need to store it like this later on for when we do collision detection. So yeah, yep. And then height, snake, height. Okay, that's good. That's the snake. We can then move on to now. When does the game actually start? It starts when the window loads. So we're going to use window.onload. Okay. So when the window loads, we want to run this function. Okay. So first of all, we need to set the screen. Document. The document is the HTML page. Get element by ID, and then remember we gave the canvas element an ID of screen. So now we're getting the canvas element, and we're setting its width. Oh, whoops. The screen dot width equals screen width, and then screen height screen dot height equals screen height. Okay. And then the next thing we need to do is set the context, which is what we'll use to draw on the screen. So very important. Screen.get context, and we'll do 2D here. This is a 2D game, so we only need 2D. Yep. Okay, and then we are going to create these functions a little later on. So first of all, we need to add an event listener for when we press a key down. So when we move in a direction, or we're also going to add, we're going to use space when we want to retry the game. So we're going to make that log. We're going to call that function. So when you press the key down, it's going to call this function log move. And the argument to that function is going to be the key we pressed. And then we want to update the screen every 0.15 seconds to move the snake. So we move the snake every 150 milliseconds. Okay. And then we also want to start an animation. We want to start a loop, a game loop. So that's what this request animation frame is for. So the first function we're going to make is going to be the log move function. So we can actually log a move. So it's going to take in E, which is going to be the key we press. Okay. And we'll make a switch statement so we can easily go through all the keys. E.key, and then case W. And obviously we can't move backwards, right? So if the direction is the opposite direction, we don't log it. Okay? That makes sense. Then we change the direction equal to W. So if you're going south, right? If you're currently going south, you can't just switch and go north because your whole snake body is going south and it's on that line. So you can't like run into your own self. So yeah. Okay. So and then we need a break. Okay. Simple enough. We just need to copy pasta this 4 times. Then we do if you're going left. If you're going right, you can't go left. Okay. If you're going south, if you're going north, you can't go south. And if you're going right, if you're going right, if you're going left, you can't go right. Simple enough. Okay. And that's pretty much it. And we'll add another case here when we finish writing like the basic functionality of the game. So the next thing we need to write is move snake because we need to be able to move the snake. Okay, so function move snake. So in this move snake function, pretty much what's gonna happen, we all we need to do is that based on the direction we're moving, we need to update the first part of the snake to move in that direction. We'll deal with the snake increasing in size later on, but for now all we need to do is add a switch statement for the direction. So if you're moving W, which is north, then all you do is the initial part of the snake just goes north. And we'll do it by tile size. So don't forget, in programming, north is usually subtracting y rather than in math, where when you go up, it's usually you're adding to y. In programming, it's usually subtracting y. Yeah. Okay. And then we need to break. And we can just copy paste this another 3 times. And if you're going south, we add to y. If you're going right, we add to x. And if we're going left, we subtract x. All by tile size. This is how much we're moving by each time. Because it's like a grid. The snake game is like a grid, so we move along the tiles. Okay? So now we have done the function for getting keyboard input, for moving the snake. Now how do we have to reflect all these changes on the board itself. Okay, so first let's add some variables which we need to. This is just some stuff I learned when creating a game from scratch. You could technically create it without this, but it just makes more sense to me having this in the Yeah, like it's a constant FPS if you have this in. So uh, the target FPS is 60. We're gonna do 60, and the frame interval. This is like by milliseconds. So uh, pretty much 1,000 milliseconds divided by 60 is the how much milliseconds is each frame. Okay, and then we need to get the last frame time. So we'll just use performance.now, which gives us the time in milliseconds. Okay. Very useful function. We need the current time, and we need the elapsed. Okay. Now, function draw loop. This is the function we declared above. The request animation frame we passed in this function draw loop. Okay. So pretty much to establish the loop, the next time they want to draw a frame, it just calls draw loop again. So that's pretty convenient. So it's pretty much like a loop. It's like this is like a recursive function kind of. Yup. So we get the current time with the same thing we used before, performance.now. Okay. And now we have the current time, right? So now we can find out how much time elapsed with current time minus last frame time. Okay. So if a frame interval has elapsed, right? If a frame interval has elapsed, then that means we can draw and paint again on the screen. So we just set the last frame time. It was equal to current time minus elapsed module frame interval. So this current time minus elapsed frame interval pretty much accounts for the extra time that was which occurred after the frame interval. Okay, so it just keeps it consistent. Okay. All right, and then we're gonna make an update function. Oh, whoa, not what I wrote. Update function and a draw function. Nope, that's not what I wrote. Very cool. Draw function. Okay. So we're going to keep this update function empty for now. So we kind of did part of the update function with just that this up here, this set interval, because that's just like simpler, honestly. Saves time. But we're going to do some stuff over here also. Okay, so that's function update, which is empty, and then function draw, which is going to be very important now. So first thing we need to draw is the screen itself, okay? So we need to do context.fill style style equals black, okay? And context.fill rect. So this is filling. So in the beginning of each frame when we draw, we first fill in the screen, the screen itself that we're looking at. Right? We need to fill that screen. So it fills at 0, 0, so the top left coordinate, 0, 0, that's top left. And it's 510 pixels wide and 510 pixels long. Okay? So that's the screen we're filling in. The next thing we need to fill in is the, let me see here. We need to fill in the snake. So align width is gonna be 3. Context dot fill style is gonna be, we're gonna draw the snake yellow. Okay, and for int, oh, this is not Java. For let I equals 0, I is less than snake dot parts dot length I plus plus. Okay. Context dot fill rect. So we're gonna fill it with certain things. So snake dot parts sub I dot x plus context line width divided by 2. So pretty much the snake itself, each part of the snake is stored as a tile, but when we draw it, we're gonna draw it accounting for this line width. Like we're gonna draw this, like if the snake is stored on this tile right here, it's gonna be like a bit smaller inside the tile, like each snake part. So that's why we add this extra context dot line width divided by 2. And we do the same thing for the y also. Okay. And we'll make that y. And we want to draw it smaller, so we subtract the line width. Okay. Let's copy paste that. Let's make it alright. Okay. So we drew the snake now. That's good. Now let's see if it works. I think it should work. Open in browser, Google Chrome. Oh, whoops. Let's load it again and let's try. Oh, look, our snake moves now. We're very nice. So we finished the first part. So now the second part we need to work on is now we need to add food, and when you eat food, you grow. Okay? So let's work on that now. Let's go back to our snake.js file. So the first thing we need to add is we need to add the food itself. So let's scroll back up to the top here and let's add the food. The food. So pretty much the x coordinate of the food is going to be randomly between the left and right side of the map. Okay, so mat.random gives us a number between 0 and 1. Then we multiply that by 16 to get a number between 0, I think it's 0, 0 to 1. So this is 0 to 16. Right, yeah. Okay, so there's that. And then at the end, we just multiply this by tile size. Pretty easy. Yep, that's pretty much it. Oh, shit. And it's the same thing for y. I can just do this, yeah. That is what I did there was shift alt down arrow, and yeah, very nice command. Okay, and then width is gonna be tile size. Height is gonna be tile size. Okay, so now we got the stuff for food. Okay. Now let's scroll down and let's make a function to randomize the food. Because once we eat the food, then it needs to go somewhere else, right? So randomize food. And we could just copy paste the stuff from up here. Yep. Just copy paste it. All we need to do. So this food dot equals semicolon semicolon. And this is food dot y equals perfect. Okay. So now we can randomize the food. Okay. So the next thing we need to do is we need to create a function, or we need to add it to this move snake function. So like if you grow, you eat food and you grow, and now you're two like bits long, right? Imagine this is like the front, this is the middle, and this is the back. Then you move forward again, right? You move forward up here. So then this middle part needs to move up here where the front one was, and this back one needs to move where the middle one was, right? So we need a function to do that. So it's very simple. We just move backwards. Let I equals snake dot parts dot length -1. Okay. Because arrays are 0 indexed. We'll do it while it's greater than 0. We don't want to do it for the first element, I minus minus. Because the first element moves on this basis, on where your mouse moves. Okay. So it's very simple. The part we're looking at just moves where the previous part was, or where the part ahead of it was. Yeah, that's the right way to say it. So it moves where the part ahead of it was. Very simple. Very straightforward. And all we do is, this is Control D to change multiple things at the same time. That's a very nice function that I use often. Okay. And now we did the move snake. So now we need to do the update function. And we need to add so we need to write the update function. So if we're gonna have to write a new function, if detect collision snake food, which pretty much tells us if the front of the snake and the food collided, right? So if detect collision snake food, so if that's true, then we know that we need to push a new part to the snake. We push a new element to the array, right? And this new part, the x and y don't really matter that much. We just have to give it a value. And in the next frame, it'll accurately update it based on where the previous snake part was. So it'll be added on to the snake array. Yep. So we want to randomize the food because you just ate it, right? So we want to move it somewhere else. And yeah, that's pretty much it for now. We're gonna add a score. Let's add a score. Score plus equals 10. Let's add a score to this. Because we want to keep track of score. Score is pretty important. So let score equals 0. Okay, so now we need to write the function to detect a collision between the snake and food. So we're gonna use something called let me search it up. AABB collision 2D. This is what we're using. Axis aligned bounding box. Where pretty much what we do is that we check. This is the left side of rectangle 1. We check if the left side is less than the right side, and we check if the right side is greater than the left side. So we check if there's a collision based on the edges of the boxes, and we treat each entity as a box, kind of. You can try to play a picture with your hand, and you can see how it all works. But it's called that's the thing we're using. So let's write the function. Function. Yep, that's what it's called. A, B. We'll just call it that. But so what we want to return. So we want to check the front of the snake. A is the snake, so we're checking if the front of the snake is the left side of the front of the snake is less than the right side. Just gonna copy paste this. Honestly, I wouldn't really worry about this. This is kind of like standard stuff that people use for like 2D gaming. So I would just familiarize yourself with just like the. Honestly, like it's pretty tough for me to like wrap my head around this. Like even now, and I've coded like a bunch of these, so I wouldn't really worry too much if you're struggling to understand it. So there's that one. There's dot y. What's the b dot y? Height. And e dot. So y plus e dot height is greater than, and let's remove all this. Just put y. Okay, this is perfect. Okay. And now let's add something. Let's add the score. So now we're keeping track of score, right? When you eat, you get some score. So let's add that on the bottom here. So context dot fill style. We're gonna make that white. Okay. Context dot font. And we're gonna make this 45 pixels sans serif. Yep. Context dot fill text. And what we're gonna fill in is, so now we're using backticks, which is usually in the top left of your keyboard. Okay. Score. The score is then we use a $sign and a curly brackets. It is the variable score. Okay. And we're gonna put this in the 5x position and 45y position. Okay. So we need to also draw the food on the screen, so we're gonna do that right now. Context.fill style equals red, and context.fill rect. Food dot x, food dot y, food dot width, food.height. So that's pretty much it. And yeah, so now it should work. Oh, yep, we can see it now. So now let's try moving. Let's pick up the food. Nice, and now we grow longer. Looks pretty cool. Yep, we're going. Okay, that's good. Okay, so now I see there's still a problem. We can just go on forever across the screen out of bounds, and we can still hit each other. We can hit ourselves. So we need to make the game over case. So let's do that now. Yep, let's go back. And now we need to make a game over variable, so we can pretty much call game over. So let game over. So when we first open up the browser, this is obviously going to be false. Okay. So this is going to be false, and pretty much the first thing we need to do is we need to add this in log move. So for a case of space, pretty much we check if game over. So this is to retry, right? We want to randomize the food again. We want to reset the snake. We can just get that from right up here, right? Oh no, we can't. All right. I guess we can just take this part right here. Yeah, we can get this part right here. We can reset the snake. Snake parts equal this. Yeah, that works. That works. The direction equals snake start direction. The score needs to equal 0 again. Game over needs to equal false. And yeah, that's pretty much everything. So now we have the game over, the retry state ready. The retry state. And yeah, so move sync is good. The draw loop is good. So we need to update our update function now. Yeah. There's a good amount of stuff we actually need to add here. We first of all we need to check if the snake hits any of the boundaries. We need to activate game over, right? So snake parts sub 0 dot x is less than 0. So if you go off the screen on the left side, then that's one. That is one game over. Okay. And we need to do the right side also. So let's add all of that. Let me just do it here. Yeah, that's good. Okay. So this is the top of the screen. Looks like is greater than or equal to screen width, and is y is greater than or equal to screen height. Okay, yep, that should be good. And when this happens, we need to set game over to true. Not Python, it's lowercase. Okay, so that's one case. And then the next case we for game over is if the snake hits yourself, if the front of the snake hits one of its parts. So we need to do a for loop where we're going through each of the snake's parts, and we check if he hits himself. So that's pretty much it. Okay. If we're going to call this detect collision with snake. Snake 0. So that's the front of the snake, and I, which is the specific part of the snake we're looking at. And if any of those are true, then game over is true. True. So let's create that function detect collision with snake. So detect, nope, not snake food. We just need, oh, I wrote this detect call snake. Yeah, nope, this is detect call snake. This is a separate function. Detect collision with a snake. So snake A, B, and rather than just rewriting everything, we can take it from here and we can like modify it. So all this dot A stuff. Oh, there's a lot of A's, so I can't use Control D. So I guess I have to just manually type in each of these. That kind of sucks. So snake, 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 okay, snake. Oh, this is pretty. Oh, yeah, this is. I can use it here. Control D, A. Okay, so we're done with this part. Now we need to B. So pretty much everywhere where B is, we want to change that to snake dot parts sub B. The only part is this width is just the regular snake width. This is just regular snake height. That's pretty much it. So B, 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 A, width, width, height, height. So that's good. So we finished that. That looks good to me. And then the last thing we need to add is I think we've added everything. Oh, we need to add the game over text. Very important. Game over. Let's get this from down here. Let's copy paste that up here. A lot of copy pasting in programming. And then let's just do game over space to restart. Okay. Oh yeah, and let's make this a bit lower, so 90. Okay, so I forgot to add something very small. I need return right here. So now if we check that file, we collect food, we go bigger, we hit the edge, let's press space to restart, works perfectly. Now let's become a bit bigger. Let's hit ourselves. Oh, let's become a bit bigger. So, okay, and we die when we hit ourselves. Okay, so this is how to program Snake, and it works perfectly. Thank you for watching, and please subscribe to my channel. See you.